SQL Server is an important database to understand as a developer, not just as a C# developer. In fact, it's one of the most popular requirements on job listings for developers. So I thought we would take a bit of time to dive into some important parts of SQL. In this lesson, we're going to look at T-SQL, the scripting language used to create, read, update, and delete data in SQL, as well as to create all of our objects like tables and databases and so on. While this language is fairly universal among relational databases, we are going to be specifically looking at the Microsoft SQL Server version of T-SQL. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier, and that includes all the things around C#. I do that by providing videos here on YouTube multiple times per week, plus I have a weekly podcast. I also provide courses on C#, web development, and much more at IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube so that everyone can have a great education in C#, not just those who can afford it. Let's go over to our SSMS. Now, if you have not seen SSMS before, check out my previous video, Intro to SSMS, where you can see how to install it, or at least how to download it, and then how to use it and the basics of it. But we're going to assume that you have SSMS installed. You can also follow along in Visual Studio. So if you have Visual Studio, we're using a local DB. You can create one or use an existing one, but you can come in here using SQL Server Object Explorer, found under the View menu. And you can do pretty much the same things we're going to do in SSMS. I'm just going to show off SSMS because that's a pretty common place to do this work. So let's go back to SSMS. And I am going to right-click on SampleDB and say New Query. As I said in my last video, I live in this window. I live in the query window where I can write queries very easily to see what's going on. So in here, I know I have a few tables, but let's look at what those are. I have two tables, addresses and people. I also have a store procedure, which the people insert. We'll look at that later. But let's look at select star from dbo.people. This is T-SQL. This is the scripting language for talking to your SQL database. Now, the very first thing right out of the gate before we start into learning this is I do not want you to treat this like C# or like another programming language. I want you to avoid things like loops and for eaches or other stuff that are about coding and about logic. I want you to focus in on a query. A query is a request for something, and it really needs to be as optimized and simplified as possible. When you start getting cute in your queries, you start doing some really complicated things, you can end up creating a mess. Remember that this query is going to operate on your table or tables, which a table could have 1 million+ records. So, for example, if you do a search where you modify a value and then compare it to something else, well, now SQL has to run that line of modification on every single row in your table. If you have 1 million records, that's 1 million updates that it has to do in memory to then do a comparison on. That is terribly inefficient. So try other ways of doing this. So just think that through. I want you to have that in your mind before you even start learning how T-SQL works. This is about asking for data in the way that's efficient for SQL, not getting cute and trying to make this into our application. There is a purpose and a value to SQL Server. There's a purpose and a value for how it does what it does. And there's a purpose and value for C# and for your application and what it does and how it does it. You do not want to make SQL do what it's not good at, which is programming. And you do not want C# to do what it's not good at, which is effectively managing or filtering through data. And yes, you can say, but SQL or C# can do it. Absolutely. And SQL can run C# code too, actually. But don't do that. Don't cross the streams, okay? Try to let each tool do what it's best at. All right. So that's kind of my, before we even get started, best practice I want you to think through. So we're looking at T-SQL here, and this is our language. So there's some keywords that are pretty common. The select is the first one. And what this says is which columns do you want? Now, star, that's not necessarily the best practice, but it is to get started. So we're going to look at how to not use star, but for now, star just means every column. So I want every column, but from where? Well, that's what the next statement is. From. Where you get your database or data from. We're getting it from the people table. So this specifies I want every column of data from the people data. Well, how many rows is that? All of them, because I do not have any type of limiter on the rows. This is the limiter on the columns. Which columns do you want? But there is no limiter currently on the rows. So when I run this using execute or F5, I get all the rows, all 7 of them. So that's all of the information from this table. Now, it's only 7 rows. It's not a lot, but just note that that's all there is. So if it's 1 million records, I'd have 1 million records trying to show up in SSMS, and that would take forever. It would clog up your SSMS. Been there, done that. Okay. So when you're thinking about your queries, be thinking about the size of them. Now, there's a couple different ways that you can limit your query so it doesn't return every row. Again, this is going to return every column. We can filter that. We'll look at that in a minute. But how do you filter every row so it's not every row you're returning? Well, the most common way is a where clause. Where. And you can specify some type of filter. For example, notice down here we have 2 different records that have Smith in them. And sorry, I'm not sure I can make this go any bigger. But we have 2 different records here that have Smith in them. So let's give us only the records that have Smith. Where, and what's Smith in? The last name column. So where last name equals Smith. Notice the single quotes. Okay, so that's going to give me all the people where the last name equals Smith. Let's run this. We get 2 records instead of all 7 records. So we already have some limitations here that allow us to reduce the row count being returned. We have this where clause. So this is a structure of a basic select statement in T-SQL. We have what columns we're getting, we have where we're getting it from, and we have the limitation, if any, on the rows. So that gets us our structure, but let's start playing around and tweaking this a bit more. First of all, note, I'm using all lowercase. That's my personal preference. It's not the old school preference. The old school preference in SQL Server, let me read this again. Select, and it screams at you. From, where. That's the old school way of doing things. All caps for all of our keywords. We don't have to do that anymore. That used to be, I think, a requirement back in the early SQL databases. But before I go any further, people often get a little frustrated with me. I might even do a whole separate video on this. SQL versus SQL. And people say, stop saying SQL, it's SQL. Guess what? It's both. In fact, I have video of Microsoft higher-ups that own Microsoft SQL Server that say both SQL and SQL in the same paragraph. Okay, the original product, I don't know if you know this, the original product for Microsoft SQL Server was named SQL, as in SEQUEL, SQL. Oops. Dash, not slash. SQL, that was the original product name. They had to change it. So they changed it to SQL. So guess what? They still referred to it as SQL, even though they named it SQL. So just a little bit of history there. Which way you say it, it's not a big deal. Stop with the gatekeeping, okay? You can say it both ways. All right, off the soapbox. But this was the original way of doing things with the all caps. Now we don't need to do that, and I personally hate the screaming. So I don't do that. I do all lowercase. You'll note, though, that sometimes when the tool creates some script for you by default, the tool by default will give you the screaming caps versions of things. So just note that's going to happen. You'll see the screaming caps in some places. It's case insensitive, so you don't have to worry about that. Okay, so we have our select, or selecting all columns. Well, if we want to limit this, well, we can say first name, comma, last name. Just those two columns. Run this again, and now we just get Jane Smith. But one of the things we're missing here is, okay, we have Jane Smith and Mary Smith, but how do we refer to these? And we can't refer to them by that number. So how do we refer to these records? Well, that's where we usually have to return an ID. So ID of 2 is Jane Smith and ID of 3 is Mary Smith. So in all of our tables, we almost always want to use the unique identifier that identifies that record in order to refer to it. Now, I use a primary key that's an integer that counts up. And that's a pretty common thing to do. Microsoft, because their size and because of some of the stuff they do, they use GUIDs, which I hate GUIDs. And there's actually a reason why GUIDs are not as performant as IDs. So, be careful of that. There's also the idea of keys that are made up of the unique information in the row. And people say, well, first name and last name, that's unique. So therefore, that will be the identifier for Jane Smith will be Jane Smith. The problem there is, what if Jane Smith decides to change her name? Or what if there's two Jane Smiths? You say, well, then we're going to use something like her social security number. Well, that's actually illegal to do. You can't do that because that's using that in an unprotected way, and it's bad. But then you say, well, we'll use her phone number. People change their phone numbers. Okay, so I would highly discourage you from using the keys that are the natural keys, the keys that are already in the row, and just using a unique identifier. It actually makes insertion into the database much faster because it inserts based upon that ID in the spot where it should go. So if it's auto incrementing, it's always the last spot. But if you have some kind of key that is a mashup of first name, last name, and phone number, well, then it has to figure out where that go and insert that and potentially move things around in your actual file structure of your data. It's a little thing, but it can add up over time. There's a number of reasons we're not going to get into today, but just note that's how I do things is based upon that numeric auto incrementing value. One more thing before we're done here. Let's run this again with just this two. By the way, I highlighted just these two rows and ran it, and now this where last name equals Smith is no longer applied. The reason why I covered this in the last video is that whenever you highlight in this window, will run just that. So if I highlight this and execute, I get an error because that's not a complete SQL statement. But this is, and it drops off the where clause, which I wanted. Just be careful of that when you might accidentally run a delete statement without your where clause. Be very careful with delete statements. But with this, I can now run just these two lines and see all my records. And one of the things I want to point out, I'll zoom in here for this. This is a question that pops up sometimes is, hey, Tim, I've got this really weird problem in my database where it goes 1, 2, 3, 4, and then it skips to 1,003, 1,004, 1,005. That's wrong, right? Like, how do I fix that? You don't, and it's not wrong. It's actually by design, and it's a good thing because this unique identifier does not matter. It is not supposed to be 1, 2, 3, 4. It's supposed to be unique. It happens to count up from 1 and continue on, but it does not rely on having every number filled in. Imagine for a minute that you deleted record number 3. Would you want record number 4 to become record number 3? Absolutely not. because then you could accidentally associate data from Mary Smith with John Doe, and if you hadn't deleted all of Mary Smith's data when you deleted Mary Smith's record. You definitely don't want to do that. You want to keep those spaces and leave them. So leave a gap there. But why is there this large gap? Well, this gap right here from 4 to 1003 happened because I turned off my SQL Server. Now, SQL Server is meant to be run continuously all the time, and it's meant to be run on a server, but we're running it locally for just testing purposes. So what happens when SQL Server is shut down kind of unexpectedly is it says, you know what, I might have still had information in the buffers. Now, what happens in very basic terms? We have log files and database files. And when you insert data in a SQL, it actually writes it to a log file first. And then it takes that log file and it puts that data into the database. And there's a number of reasons for this we're not going to get into. But if the system crashes and then SQL starts back up, it says, you know what? There might be data in that log file that I have not yet put into the database. So while I'm figuring that out, because I have to be running while this is happening, but while I'm figuring that out, I'm going to put a gap in place in my numbering, okay, from 4 to 1003. So I'm going to put a gap there because that way, if I have even 100 records in my log files, they can be numbered 5, 6, 7, 8, 9, 10 through 104. And I'll still have not stepped on any toes of the new records that are being inserted while I'm figuring that out. And so it puts that gap in there intentionally in order to be safe. It takes care of that. You don't have to worry about it. And don't be concerned when you see that gap. It's mostly a gap you'll see in development because you're turning your development server on and off repeatedly as you shut your computer down or as you get updates or as your computer crashes, whatever. And that's not something that normally happens in a production environment. A production environment that shuts your SQL Server off continuously is a big issue and probably not something you should be continuing with. And you should be changing off of that to a real production environment that is on 24/7. Okay, so just want to point that out as well while we're here. So we now have limited the columns. We have asked for one table, and we have limited the number of rows. But what if we want to go further than this? Let's run this again. We have Jane Smith and Mary Smith, and they're actually in a order that seems correct. But what if we wanted to change the order? Maybe we want to say, hey, who was the last Smith to be put in the database? Well, we could base that off of their ID because an ID of 3 was inserted after an ID of 2. Well, we can do an order by. So that's a 2-word keyword. A key phrase, I guess, is better term. Order by ID. Okay, I'm going to order by ID. But if I run this, it still says 2, 3. That's not what I wanted. That's because by default, we're ordering an ascending manner, meaning the smallest thing at the top, the largest thing at the bottom. But if that would be ASC. But if we said DESC for descending and execute this, we now see that ID of 3 is at the top, Mary Smith, and Jane Smith is at the bottom with ID of 2. So we have now changed the order. If we were to comment out this where clause and run this again, notice that the 1005 Greg Alcott is at the top and Tim Corey with ID of 1 is at the bottom. So this order by allows us to change the ordering of our records. And we can add multiple of these. We're going to get into more complex statements in a little bit, but this is the basics of our select statement. We're going to spend a lot more time on select than we are on insert, update, and delete, but we are going to get to those, so don't hang with me. But let's look at a more complex example. So we have a select star from dbo.addresses. Again, I use this window as my scratch pad. So having the ability to put another query in there and just highlight and run, really helpful. Also notice I hit my enter key a number of times afterwards to give myself some blank space. And the reason why is because it's easier to just start grabbing. You notice I grabbed an extra couple of lines, no big deal. Blank lines don't matter. That's not awful bad. Blank lines don't matter. Black lives matter. There's a difference. But by grabbing these, no big deal. Okay. But if I don't have these here, let's get rid of them. And I go to grab from down here, it can be a little tricky sometimes. Okay. Now it's not a big deal, and it is, if I click down, down the very bottom and drag, it will correctly grab it, but it's just easier, I find, to have those blank lines there to quickly click and grab. I also usually put a couple of blank lines here so I can just, again, grab really quickly without having to be ultra precise. So that's why you'll see these bars at the top. I just grabbed and highlighted real quick. So now we can see that this, I have this list of cities, I have this list of person ID, and I have this list of ID. Well, what is this? This is the addresses. In fact, it's just cities. And there's kind of, 4 cities I know about. But I said, okay, well, we're going to associate, this with person 1, this with person 2, and this is person 3, and this is person 3 as well. So how do I link these two? So how do I, get in here? And let's comment this out because I don't want that. Again, double dash is comment. How I associate, let's change this order to ascending. How do I associate Tim Corey with the first address? Because he is address 1, and Mary Smith has 2 addresses, which is just 2 cities. But how do I associate this list? Well, there's a number of ways of doing it, but the easiest thing to do is to have a join. Now we're going to look at how to do a join and then where joins can go wrong. And you have to understand what to do when things break. Okay, so let's say select. I always start with select star because I want to get into what the query is first. Select star from dbo.people. Okay, so I want all people. And I want to join. So before I do that, I'm going to rename people because saying dbo.people all the time is a little bit laborious, especially since when we specify our columns, we're going to have to specify, is this a people column or is this an address column? We're going to have both of those columns intermixed in this query. And so what I'm going to do is I'm going to rename dbo.people. The way I do that is put a space afterwards and just give it a name. In this case, I'm going to call it P. You might say, well, Tim, that's awful short. And the answer is, yeah, that is awful short. That's okay. This is just for this query. Unlike in C#, where we try to give more complete names, for our SQL queries, we tend to use single letters or very, very short abbreviations to specify a named table. In this case, I'm going to call the people table P because P stands for people. And then you may have guessed, for addresses, I'll call it A. Now, up here, I could have done the same thing. So I could have said P up here. And if we did that and run this, no big deal, it still runs. But I could say P.ID, P.first name, and P.last name. And it will run the same exact way. Okay, because I'm just specifying, I could have said dbo.people.id. Okay, but that's yelling at me. And the reason why is because I've already specified the people is actually P. So let's take P off. I could have done this for every single name. Okay, that way if I had 2 different tables in here, we'd know, but we've already got that much space being used up for 3 columns, and it's kind of hard to read. That's why we do this. and then we just specify P. And again, you only have one table. You don't need to do this. Okay, it's not necessary because we only have one table, and SQL can figure out where the ID comes from. And in fact, if in our query down here we're going to bring in addresses, it'll be able to figure out where city comes from because there's only one table that has city in it. But it's still better to specify, especially since there are columns that's not going to be able to figure out. ID, for example. There's an ID in the people table and an ID in the addresses table. Which ID do you want? You have to specify either p.id or a.id. And that's where that rename really helps. So let's start with this select statement. Cool, still works, great. But I want to get actually all these columns. So I'm going to say, I could say p.star, that still works. But it's usually better to specify the columns. So ID, p.firstname, p.lastname, and p.state. Now, why is it that it's better to specify the columns instead of having a star? Well, the reason why is because if I come back later and I say, let's add a new column, it's going to change this query without me intentionally changing the query. And that might not be ideal, especially if the application that's using the query expects things in a certain column order. That's going to mess that up. So it's better to specify and then not be reliant or not be beholden to any changes that might change the order or add new columns that we're not expecting to add. Also, it really makes us think about, do I need all of these columns? Because if I don't need all the columns, then I won't specify them. That way we're sending less data across the wire if somebody's requesting this outside of SQL Server. There's no reason to ask for more data than you need. Now, the other thing that the sharp-eyed among you may have noticed is that there is a color pattern here. So select and from are blue, and then I've got my text that I write is black, but over here we've got a blue name. That's because this is technically, state is a somewhat reserved name. So what do I do here? Well, actually, nothing. It's fine. It'll run just fine. But if you want me doubly sure and say, no, it's not the reserved word state. It's not something else. It's actually the state column. It still runs. What we do instead is we put this in square brackets. Like so. So now it's no longer blue because it's saying, no, not the reserved word, the column. Okay, and that's what that square brackets are for, is to help with any kind of conflict between SQL's reserved words and the words you used for your tables or columns or whatever you used. So that still works. Notice it doesn't put the square brackets in the column name. It just puts the name there itself. Also note that you can rename things. So p.firstname as given name. So as specifies the new name. So if I run this query again, notice that this column now says given name. This is how you can match up to, let's say, a C# model. I would encourage you to match your C# models up to your column names, but in the case where you can't or it makes more sense to do it the other way, you can just rename your columns. This does not affect the actual table. It just affects the query results. So this allows you to rename things. Just say as and then give the name you need. So there you go. That's how you would rename anything you want. I'm going to put this up. Let's cut this out of here. We don't want it here, but let's put it up here. Okay, we're going to save these for you, but or you can retype these. I'm not going to necessarily give you the download for it, but I want to kind of group things around so you can see them. Okay, so we've got the start of our query, but we still want to bring in addresses. So we want to bring in that city. So how do we do that? Well, we're going to bring in the addresses using a join statement. And we have a few options here. We could do an inner join. Okay, so an inner join, what it's going to do is say, hey, where do these two connect? Where do they intersect? Where the records in addresses match up with the records in people. Only give me those matching records. All right, that might not be what we want here, but we're going to see. I'm going to show you first. We're going to go back and change these so you can see the different options. So it's still yelling at me because we're joining. We're saying we started with the people. We're saying inner join addresses A. We have to specify how we're going to join. On p.id equals a.personid. Now, this is where my naming convention, a pretty common naming convention, comes in that sometimes people get a little uptight about. Guess what? You get to choose. You get to choose how you do your naming, but here's why I do the naming the way I do. I use ID as the primary key for every table. So we have, in the addresses table, we have a field called ID. In the people table, we have a field called ID. You might say, well, Tim, that's so super confusing. They all have ID. Yes, but they're all the ID for that given table. So the ID in the people table is for the people table. And the ID in the address table is for the address table. You might say, well, yeah, but Tim, when you're going to join them, you have confusion. Which ID is which? Well, no, you don't, because you have to specify anyways, or you should be specifying anyways. It's the person ID. And you might say, well, Tim, why don't you just name it person ID? Well, guess what? I have a person ID. I put that in the addresses table. So if we look at the addresses table, and we'll zoom in here, I have a person ID. What's this? It's called a foreign key. And so this is the primary key. Okay, ID is a primary key. This is the foreign key. What the foreign key is, it says, I'm going to link to another table's primary key. Well, how do I know what primary key I'm linking to? Well, if I call it person ID, guess where it's probably linking to? The person table. Okay, so by specifying that, I can specify which table it's linking to, and I know because it says person ID that this is a foreign key. Now, if I call this column address ID and this column person ID, it would not be as clear which one is the primary key and which one's the foreign key. But because I named one ID and I named one person ID, the person ID is the foreign key and it refers to the person table. So that's a pretty common way of doing your primary key versus foreign key. The question may come up, what's a foreign key? Okay, great question. And we're going to not get into too far into database design. I have a whole course in this, by the way. But let's talk a little bit about foreign keys versus primary keys. A primary key is the unique identifier per row of your table. Okay, that's the primary key. A foreign key is what links to usually that. You can't link to other IDs, but we're going to specify by default or by standard common way of doing things is to link to the primary key of another table. So we say, hey, person number 2 lives in Scranton, Pennsylvania. Okay, so this specify is a foreign key, meaning it refers to another table's entry. And what is a table? The person table. And it's the primary key in the person table. So because of referring to a primary key somewhere else, it's a foreign key. That's all it is. So let's look at this in action. So we have inner join DBO addresses. We're saying, and we named the addresses A. We're saying on. Here's how you join the addresses to the rest of our query, to, in this case, just the people. Well, the way we join it is by saying that p.id, that's the person table, the ID, that's the primary key, is equals the address table person ID. That's the foreign key. The foreign key equals the primary key in this other table. That's how we link the two together. Now, if we were to update our select statement, we can say a.city. So the city, we can actually move this around. Let's cut this out from here and put it in here. So it's city and state. And we can run this query. And now we have Tim Corey, Caddo Mills, Texas. We have Jane Smith, Scranton, Oklahoma. Oh, that's interesting. I know there was a Scranton, Oklahoma. These are just randomly chosen things. But Mary Smith in Elyria, Ohio, and Mary Smith, Miami, Ohio. Well, that's really interesting. First of all, Miami, Ohio sounds interesting. But there's a school, Miami of Ohio? I'm not sure. Anyways, we've got Mary Smith repeated twice. And in fact, look at our ID of the person. It's the same ID. So we've got a repeat here. That seems like a problem. And also, we have an issue where we don't have all of our records. Where's the records that start with 1004 and above? They're not here. Well, that's because we use an inner join. And the inner join, remember, says that I want to see all the records from the people table and all the records from the address table where they have an overlap. Okay? So they only have an overlap with these 4 records. That's it. So we don't see the other records because there's no overlap. There's no referencing address for those other people. Therefore, we don't see those other people. That's what an inner join does for us. But then we can change this, and we'll change it in a minute, to be a different kind of join and see all the records from one table or the other. Now, why do we have a duplicate? Well, if we remember, if we look at the addresses, and let's run just this, we have 2 records that have a person ID of 3. One that says Elyria and one says Miami. So when we run this query, we have to highlight the whole thing. There we go. We get 2 records, but we repeat Mary Smith in Ohio. Mary Smith in Ohio. ID of 3 for each. So we have that repetition. You might say, well, Tim, that's bad, right? No, it's not. It's actually right. Because how else do you want to represent this in a table? We have 2 entries for 1 person. How else do we show the other entry? You have to duplicate the data because it is duplicated. So this is something you have to think through when you're trying to do a join is how does it actually lay out in columns and rows? Because you couldn't just have this information be empty and just have Miami and then kind of like tag it to this. That's where NoSQL databases really have a leg up is they don't have to show you a nice, neat table structure with columns and rows. They can show you an object that has different things attached to it. But that's how you represent Mary having 2 different cities. Now let's zoom out here. Let's look at the different join options. Again, remember, we didn't include all the people. So if we were to look at the people list, we have 7 people. But when we look at this list, we have 4 records, but only really 3 people because Mary Smith's repeated twice. How do you get all the people? Well, we do what's called a left join. What is a left join instead of an inner join? Well, a left join says, I want you to give me all the records from the people and all the records where the addresses match the people. So don't give me the places where the addresses don't match the people, which we don't have any of those. But do give me all the people, including the ones that don't match addresses. Now, how do I know that left join says all people and not all addresses? And, you might say, well, it's based upon this. No, it's not. It's not based upon this. What it's based upon is left join says the previous stuff, okay? The left. Think of this as the left. Think of this as the right. If we were to lay us out without the line returns, like so, then the left join says everything to the left of me versus everything to the right of me. Because there is a right join, and that would be, the right join would be everything in addresses and whatever matches from over here. All right? So that's how you kind of think through left versus right join. So let's look at left join. Okay, so now we have 8 records, which we have 7 people. But again, Mary is duplicated. One's for Elyria, one for Miami. But then we have these other 4 people that did not have a matching or corresponding city. So what do we get? We get null entries because there isn't a city for those people. And that may be the right choice for you. Again, you have to think through, well, how do I want to see it? Whenever you say, SQL's broken, it's not doing what it's supposed to do. First of all, you probably did something wrong. But second of all, I want you to get an Excel spreadsheet and figure out exactly how you want your data to look. Because when you start doing that, you'll realize, I can't just have Elyria and Miami both listed on one row. It doesn't work that way. So how do I list it? Well, I'd add an extra row, or maybe you say, I want only the first record, and that we can get into that in a minute. And then what do I do with the people that don't have a city? Do I want to not show them? Well, that's an inner join. Or do I want to show them and just have what for the city? Well, null if there's nothing there. Okay, so that's, again, it's logical how it's doing it. If you kind of get angry at it because it's not doing what you expected to do, it's because you didn't tell it to do what you were expecting. So that's kind of my point on that. All right, so there's your left join and your inner join. Again, right join would say everything from address, which won't really change this query compared to an inner join. It's the same thing. But probably what you're looking for is a left join here. And you're just going to say, hey, you don't have a city for these people. That's probably what you're expecting. Okay, now you can put a where clause on here as well. So where, city equals, Miami. And it goes, I can do that. But you really should say a.city for addresses.city. And if I do that, I get one record. It's Mary Smith from Miami, Ohio. All right. So you can put where clauses. You can put order by on there as well. Just specify which table it's coming from to be more clear. Again, you don't necessarily technically have to. It still runs. But what it's really doing is having to figure out which one has the city column. And instead of making it figure out, tell it. Just tell it. Okay, so that's a more complicated select statement where you're kind of joining multiple things. You can join a third thing, a fourth thing, a fifth thing if you want. You can also, just so you know, I'm not going to go into details on this, but you can also put a query in place of a table. All right, so let's just copy this. I'm just going to show off doing this. Let's get this out, and I put an open and close paren. All right, and in here, I'm going to put some line spaces. I'm going to put select star from dbo.people where last name, and we'll say not equal to, last name is not equal to Smith. We're trying to eliminate Mary Smith's messiness, right? So that right there is a T-SQL statement that's a subquery that we're wrapping in parentheses and then naming it P. And let's not include the where clause. So we'll just highlight from this up and execute. And there we go. We've got our list, and it's a little odd because we're missing Mary Smith, but we're also missing Jane Smith. So we're missing another person that had a link. So let's come back up here to people. We've got Mary Smith and Jane Smith. We're missing one. We don't want Mary Smith. We do want Jane Smith. So we'll say where last name is not equal Smith, and first name does not equal Mary. Okay, so give me everything where the last name is not equal Smith and the first name is not equal Mary. Let's get rid of the where clause entirely. Execute. All right. Well, that's not right because we still have Jane Smith. And you say, why is this not right? Here's the cool thing. Because I spaced this the way I did, I can just highlight this part and run it. And notice that we're missing both Smiths. Well, why? Why are we missing both Smiths? Well, because we said where last name is not equal Smith and first name is not equal Mary. Well, if Jane Smith comes up, last name is not equal Smith, oh, it does equal Smith. Therefore, Jane Smith's not included. Doesn't matter if her first name is Mary or not. So we've got a broken query here, but that allows us to debug this and go, oh, that's not right. Let's change this just to first name that's not equal Mary and see if that works. And it does. And actually, the more ideal thing to do probably would be to say, since we're eliminating one record, where ID does not equal to 3. And if we run this, it gets the same results as the not equal Mary. And that way, if we have a Mary Storm, well, then no problem. That Mary will be included because we're not basing off of first name does not equal Mary. So you can kind of debug your subqueries like this and then get to your larger queries and go, oh, that's what we want. We want to see 6 records for the 6 people. The one person that was missing was Mary Smith because Mary Smith had 2 records and that was causing problems, whatever. But that's how you kind of do a subquery in here. But again, remember back to the first thing I talked about. Be careful not to start going crazy. Because you could say, well, actually, we could do a subquery inside the where clause, and go down that road. And all of a sudden you have 8 different nested queries. Well, how complicated is that to run? Well, it can get quite complicated. Okay. Notice we're already doing a little bit of a complex query here. That's getting a little, confusing. So you don't have to do this much work. In fact, we can do a comparison here. If we copy this, and this is where, again, that execution plans help, is let's get rid of this and just say from dbo.people, call it P, and then put a where clause at the end, where p.id is not equal to 3. Let's compare these two and see execution plan-wise, oh, they're the same. Doesn't really matter which one you do. So that's a little less complex than having this nested query here. So let's just do this. All right. And then you go, oh, I get it. It's simpler. So you can make decisions based upon how it actually works. And in fact, I would probably test this one more time with an actual execution plan turned on and look and yeah, there's still 50%. So therefore, I would choose this one. It's simpler. All right. But I'm going to leave the other one on the screen for a little bit so you can see it. And again, copy it if you want. By the way, I'm not giving you this. It's just too complicated to try and give you this information. But if you want to see how to create these tables, here's what I'll do. You can, first of all, pause the video and grab these queries that I've written. But let's also right-click on the people and say Design. And let's zoom in here for you. There's the design for the people table. That's all it is one ID. It's a primary key. And by the way, if you look down below, okay, the ID under identity specification, open that up, is identity is turned on. It says yes under is identity. You have to turn that on in order to have your auto incrementing ID. And then for the people table, or I'm sorry, address table, again, that's turned on, that's auto identity. But other than that, there are the 3 entries. That's all it is. Sorry, I didn't show you that earlier, but you can recreate the tables and put your own sample data in there. Okay, so there's our select statements. Let's jump into a few more. Again, this is an intro. We're just skimming the surface of this, but let's get into our other CRUD actions. Create, read, update, and delete. Well, let's do an insert into dbo.people. So we start off with inserting where? Inserting into the people table. And we have to specify what we're inserting into. So we want to say first name, last name, and state. Okay, and again, we can put that in square brackets to specify that is the column. Values is the next line. And then we specify in parens with single quotes, Joe Jones, and let's say he is from, I don't know, Florida. Okay. By the way, I have not been doing this in this demo, but I really recommend doing it in production especially, but put your semicolon at the end of a statement. Okay. It's not required by SQL at this point. It may be in the future, not sure. But this really just tells SQL, hey, we're done now. Okay. That can be especially helpful when you're doing things like having where clauses that maybe you're commenting out or not wanting to run or whatever. You can have a semicolon that just says, nope, we're done here. So if I accidentally highlight too much, it'll error out on me. Okay. So what this does is it inserts into the people table and it's saying in the first name column, last name column, and state, these values, and they correspond in order. First name column, last name column, and state. And it says values here. You may say, okay, so it's the 3 column values. Yes and no. We can also put a comma here and put another paren and say, I don't know, Barb Jones. And she actually lives in Utah. Like so. So we can have multiple values being inserted at once using this query. Normally we'd see just one entry and that would be it, just this, but you can put a comma at the end and just put more values. You don't specify values again. It's just the parentheses separated or grouped lists. Okay, so this is an insert. If we, first of all, let's go back to our people. This is where, again, a scratch pad is so nice. Well, I don't have it as just select star from people. Oh, right there. Boom. So we have 7 entries right now. We're going to add Joe and Barb. We don't have a Joe or a Barb in here. Cool. So let's run this. Execute. 2 rows affected. 1 row affected. And if we look at now people, execute. Now we see, again, we skipped some numbers because, again, I have not messed with this database in a while, and so it's crashed more than once. But now we have Joe Jones from Florida and Barb Jones from Utah. So we now have 2 extra records. That's our insert. Now let's look at an update. Let's update Barb's last name to the Corey. Okay, so update. We're update dbo.people. Now here is where some wisdom from an older SQL developer comes in. You next specify what values you want to set in the query order. However, what I recommend doing is hitting enter once and putting your where clause. Where, and let's update based upon ID. It's a pretty common thing to do, where ID equals 2003. Okay, so that's Barb's record. And yes, it's yelling at me saying, I don't know what that's for. We're expecting a set. Yes, we are. So set last name equal to Corey. Now, why is it that I would put the where clause first, even though set comes next? Because if you accidentally get distracted, let's say you write the set and then your coworker comes in and says, hey, have you seen this latest video on YouTube or this latest TikTok video? And you go and watch that for a second, you come back and go, oh, what are they doing? Oh yeah, that's right. I was updating the database. Cool. And you run this query. Or you even do this. This is scary. Don't do this. Don't highlight just this. Because what this will do, and every SQL developer who has worked with a database for any length of time has done something like this, either in development, if they're lucky, or in production, if they're normal, where they have run this kind of query. Look at just what's highlighted and tell me which people are going to get updated. If you answered everybody, you'd be correct. So now the last name of every person in my table will be Corey. Now with 9 people, not a huge deal. With 9 million, that's kind of a big deal. So be very careful with update statements. Insert statements, no big deal. You just insert a new record. It's not the end of the world if you have to delete it back out. An update statement, you can cause some massive issues. And we'll actually cause a massive issue at the end just for fun. But make sure you have your where clause in place. And the way you can do this, the way I like to do this is I like to do a select star from people and test the where clause and then change it to update and set. Okay, so update, table name, set which columns. You can put a comma and put more columns. So, comma, state equals, or state equals, and then put a value there. If you want to change to California, like so, if you want multiple values. But we're just going to do the one value. And so you have your set, and then you have the where clause. Again, very, very important to have a where clause. And the where clause needs to be limiting. So that's why I do a select first with that where clause to make sure it's the right data that I'm capturing. So I run this and I execute. It's done. And now, by the way, the extra row affected is the execution plan. So if we run this now, it's just one row affected because there's no execution plan being shown. I ran it twice. No big deal because I'm updating the same person. Now, if we grab this select and say what people are there, we have this entry right here for Barb Corey from Utah because we've changed Barb's last name. So that's an update. And then we have delete from dbo.people where ID equals 2002. That's going to delete Joe Jones from Florida. Again, this is a very dangerous query to run, especially if you do that. Again, without the where clause, what it's going to delete? Everything. It's going to delete everything. Not a good thing. Which is why what I do is I say select star from DBO people where ID equals 2002. And I go, okay, that's only going to give me Joe Jones. That's the person I want to delete. Therefore, I change select star to delete. And now I have my delete query. Now, why is there no delete star or whatever? Because delete's going to delete the entire row. There is no half delete. There is no delete only certain columns. That's going to be an update statement. You'd say update set last name equals null. But if you want to delete the entire row, use the delete key, the delete statement. But that means you don't have any limitation or specification like star. No delete star from. You're just deleting. So delete from dbo.people. Again, be very careful of the where clause. We execute that, one row affected. We come back and look at our people table, and now we do not have that ID of 2002, which was Joe from Florida. So that person is missing now because we deleted them. So that's our full CRUD actions: create, read, update, and delete. Those are all the things you want to do with T-SQL just in terms of working with data. Now, there's a lot more you can do. For example, we can create tables. So if we were to right-click on the people table and say a script table as create to new query window, this is the actual create statement right here. But this is SQL. And again, it's screaming at us, create table. If I were to type this out, I would have said create table, like so. But I didn't, SQL did, therefore it's screaming at us all over. It's annoying, but it's old school. What can I say? So this is T-SQL as well. It can actually create a table or create a view or create a stored procedure. In fact, stored procedures, that's pretty much all we have is T-SQL. We don't have a designer window. So this is the actual, we can get rid of this. This is the actual text for creating a stored procedure. Notice that I created this by hand, therefore we have lowercase begin, lowercase insert, and into, and values, and end. But we have alter procedure that was created by the system. So this allows us to create some pretty powerful things in T-SQL, not just queries. We can create also objects, databases, and tables, and all the rest, or drop tables, or drop database, or a lot of stuff is also very, very powerful, which again is why if you watch my video on store procedures, and I highly recommend doing so, one of the things I talk about is the fact that you do not want to give your application full database rights. You do not want to give it the ability to do anything. And if you're using Entity Framework, you kind of have to. But the reason why is because you could do things like drop table, and it would drop the table. You may say, well, Tim, I'm never going to do that. That's great. I'm sure you won't until you do. But what could happen is if you somehow allow a person to run SQL that you did not authorize, like a SQL injection attack, which can happen, even with things in place to try and prevent it. But if that happens, if the login name does not have rights to drop a table, then they can't drop a table. Okay? So T-SQL is very, very powerful. It's not just for talking to data itself, like we've seen so far today, but it's also for modifying actual objects in your database. So just be careful of that. But what we've seen here is the basics of how to do create, read, update, and delete from our data. Now, you can take these queries and put them right into C# if you want and run them against your SQL Server, but I'd recommend wrapping them in store procedures and calling those store procedures to do this work. And there's reasons for that. Again, that whole video specifies the security implications, speed implications, the safety implications, and so on of doing so. But that's it. That's how you query data. And you can start to dive into more information about this. There's a lot more you can go into. Again, this is just a 1-hour overview introduction to the T-SQL language, scripting language, and how to work with data using it. Hopefully you get some information on here. By the way, let's go ahead and cause some mayhem. Again, what happens when you forget a where clause? Let's run this. That's when you know you messed up. When you go, I was expecting to update 1 row and somehow 8 were affected, or again, in the case of production, 8 million. So you go and look at your table. You kind of don't want to, but you do. And you go, oh, look, we're all Corys now. Everyone's a Cory. Cool. That's a problem. And there is no undo button. You look around for, where's the undo? Yeah, undo. That's going to change this. That's not going to change the query that you ran. That's where you have to go into maybe even restoring from backups. Okay, there are some other potential ways of going about it, but restoring from backups is usually the best option, which brings me to another point, and that is that you need to have, especially in production, you need to have good backups you can quickly rely on. Because if you do this, and it's the middle of the day, how long is it going to be before you can restore that backup? And before you answer, I want you to think through another point. How far back was that backup? How much data have you lost? And how much time is it going to take? Because you have to take your SQL Server down while you restore the backup. So now it's not just about, we have to restore from backups, but it's how old is that data? So how much time have we lost? And how much time is it going to take to get it up? So the mean time to recover is a big deal. It's not just, do we have a data? It's, are we going to lose a day's worth of work or a week's worth of work? What's it going to be? And how bad is it going to be? You might say, well, Tim, updating the, my keyboard's getting low. No problem. It may be, no big deal. We're changing the last name. We can change it back. No problem. Yeah, well, that's when you actually run this statement instead. And you go, let's look at the people table, and it's empty. None of my queries seem to be working now. What's going on? Well, you done messed up. Okay, so that's where knowing how to restore your database is important. I also have a video on this channel about working with SQL databases in Docker. And one of the things we talk about there is how to automatically test your backups and restore them in a Docker and create a development environment really quickly and scripted. So you don't do anything. You just say, do it, and it's done. And all of a sudden you have a new SQL Server installed in a Docker container on your computer, which means you can shut it down and not have it take up resources. But that is a test of your production environment, but yet sanitized. And it's a test of your backups to make sure they work, to restore them. So all good things you need to think through when working with SQL, that you be very careful, because the lifeblood of every company, and I can pretty confidently say every company, the lifeblood is the data. So when you destroy data, that's a bad thing. So you make sure that you protect data as much as possible. And part of that is knowing key things like putting the where clauses in, testing that, and starting with select star from this and only change to delete when you're confident in this statement and things like that. Those are kind of things that are important to think through to work in a dev environment, not production. Don't ever query in a production database for testing purposes. Okay, do it in a dev environment. That way, mistakes don't cause you your business or cause you massive financial implications for your business by doing so. Okay, so that is the intro to T-SQL. Let me know what you think down in the comments. If you have comments, questions about T-SQL, if you want to see a future video on something else inside of SQL Server, let me know by going to the suggestion site, suggestions.imtimcorey.com, and leaving a suggestion there or upvoting one that's already there that covers your topic. Thanks for watching, and as always, I am Tim Corey.